By the end of this lesson, students will be able to use the triangle proportionality theorem to understand the relationship between triangle sides and segment lengths, and to write and solve algebraic proportions. The triangle proportionality theorem states that if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. The converse of the triangle proportionality theorem states that if a line divides two sides of a triangle proportionally, then it is parallel to the third side. There are two problem-solving approaches. Here's problem-solving approach number one. First step is to identify the sides of the smaller triangle. The second step is to identify the sides of the larger triangle. The third step is to correspond the parts of smaller triangle to the larger triangle. The fourth step is to write an algebraic proportion. And the fifth step is to solve the algebraic proportion. The first step of another problem-solving approach would be to identify the sides of the smaller triangle. The second step would be to identify the segments of the larger triangle, which are not included in the smaller triangle. The third step would be to correspond the parts of the smaller triangle to the segments of the larger triangle. The fourth step is to write an algebraic proportion. And the fifth step is to solve the algebraic proportion. What is the length of line segment NR? The first step would be to look at line segment PN and line segment QR and realize that they're parallel to each other. Therefore, due to the triangle proportionality theorem, we know that the line segments of the triangle are proportional to each other. So line segment MN divided by line segment NR is equal to line segment MP divided by line segment PQ. In other words, 9 divided by NR is equal to 6 divided by 4. The rest becomes algebra. We cross multiply and get 9 times 4 equals 6 times NR. 9 times 4 equals 36, which equals 6 times NR. The next step is to divide both sides by 6. 36 divided by 6 is equal to 6 times NR divided by 6. 36 divided by 6 is equal to 6, and then 6 times NR divided by 6 is equal to just NR. Therefore, 6 equals NR. The second approach to finding NR would be to correspond the parts of the smaller triangle to the parts of the bigger triangle. Therefore, the smaller triangle is represented by line segments MN, MP, and PN. So MN equals 9 and MP equals 6. The part of the bigger triangle that corresponds to the 9 of the smaller triangle is 9 plus NR. And the part of the bigger triangle that corresponds to the 6 of the smaller triangle would be 6 plus 4. So 9 divided by 9 plus NR equals 6 divided by 6 plus 4. The rest becomes algebra. We're going to cross multiply. 9 times 6 plus 4 is equal to 6 times 9 plus NR. And simplifying, we get 9 times 10 is equal to 6 times 9 plus 6 times NR. 9 times 10 equals 90. 6 times 9 equals 54. 6 times NR. The next step is to subtract 54 from both sides. 90 minus 54 equals 36. 36 equals 6 times NR. The next step is to divide both sides by 6. 36 divided by 6 is equal to 6 times NR divided by 6. 36 divided by 6 is equal to 6. And 6 times NR divided by 6 is equal to NR. Therefore, 6 equals NR. What is the length of line segment DF? The first step is to look at line segment HF and JG and to see that they're parallel to each other. Therefore, due to the triangle proportionality theorem, we know that the segments of the larger triangle are proportional to each other. Therefore, line segment DF divided by 6 is equal to 12 divided by 8. The rest becomes algebra. We're going to cross multiply. DF times 8 equals 6 times 12. 6 times 12 equals 72. So 8 times DF equals 72. The next step is to divide both sides by 8. So 72 divided by 8 equals 9, and 8 times df divided by 8 is equal to df. Therefore, df equals 9. Another approach would be to correspond the parts of the smaller triangle to the parts of the larger triangle. The parts of the triangle, the smaller triangle, are line segment DF and line segment DH, which is represented by 12. And then the parts of the larger triangle are DF, or line segment DF, plus line segment FG, which is equivalent to 6. And the other part of the larger triangle is line segment DH plus line segment HJ, or 12 plus 8. So the line segment DF of the smaller triangle corresponds to line segment DF plus 6 of the bigger triangle, and the 12 of the smaller triangle corresponds to the 12 plus 8 of the bigger triangle. The rest becomes algebra. DF times 12 plus 8 equals DF plus 6 times 12. 12 plus 8 equals 20. So 20 times DF equals 12 times DF plus 72. The next step is to subtract 12 DF from both sides. 20 minus 12 equals 8, so 8 DF equals 72. The next step is to divide both sides by 8. So 8 times DF divided by 8 is equal to 72 divided by 8. Therefore, DF equals 9. Given the diagram, determine whether line segment MN is parallel to line segment PQ. The converse of the triangle proportionality theorem states that if a line divides two sides of a triangle proportionally, then it is parallel to the third side. Therefore, if line segment PQ is parallel to line segment MN, then 54 divided by 42 should equal 48 divided by 36. If they're not equal, then the two lines are not parallel to each other. That is, line segment PQ is not parallel to line segment MN. So let's divide 54 divided by 42, and 48 divided by 36. So 1.28 does not equal 1.33. Therefore, line segment MN is not parallel to line segment PQ.
Students should be able to use the triangle proportionality theorem to understand the relationship between triangle sides and segment lengths, and to write and solve algebraic proportions.